students, before I begin the today's video, I just wanted to interact with you through an earnest request. That is, please watch the videos that we are uploading on a regular basis. Watch the videos without fail, because when we are seeing the views, unfortunately they are very small in number. So therefore, we earnestly request you to go through all the videos. Not only that, actually you just recommend the videos to your friends as well. Thank you. If the two circles x square plus y square plus 2gx plus 2fy equals to 0, x square plus y square plus 2g dash x plus 2f dash y equals to 0 touch each other, then show that gf dash equals to fg dash. Since these are not numerical values, therefore for sure we don't know how these two circles touch each other. What I mean is, the two circles touch each other externally or internally. If the two circles touch each other externally, then C1 C2 is equals to R1 plus R2. If the two circles touch each other internally like this, then C1 C2 is equals to R1 minus R2. Touch each other externally, C1 C2 is equals to R1 plus R2. Therefore, can I take C1 C2 is equals to R1 plus R minus R2, because I don't know for sure in which way these two circles touch each other. So let us take these two circles be S and S dash. Let S x square plus y square plus 2gx plus 2fy equals to 0. S dash x square plus y square plus 2g dash x plus 2f dash y equals to 0. The center for this is C is equals to minus g minus f, and radius is square root of g square plus f square minus c. For this, C dash is the center of the circle, minus g dash minus f dash, and R dash is equals to square root of g dash square plus f dash square minus c dash. Otherwise, to avoid confusion, R1 R2 is what we are taking, and C1 C2 is what I will take instead of C dash. Now, C1 C2 is equals to distance between the line joining of the two center of the circles. So x1 y1, x2 y2. So x2 minus x1. So minus g dash minus of minus plus g whole square plus minus f dash plus f whole square. So this is our C1 C2. And what is R1? R1 R2 are already there. So since the two circles touch each other, I don't know whether the two circles touch each other internally or externally, for which I will take the generalized condition to be C1 C2 is equals to R1 plus R minus R2. If it is R1 plus R2, two circles touch each other externally, one lying outside the circle, and R1 minus R2 absolute value, that is the two circles touch each other internally. Now this is equals to C1 C2 whole square is equals to R1 plus R minus R2 whole square. This is equals to C1 C2 whole square is equals to R1 square plus R2 square plus R minus 2 R1 R2. And what is the C1 C2? This C1 C2 whole square is square and root gets eliminated. Therefore, this is minus g dash plus g whole square plus minus f dash plus f whole square is equals to r1 square is square and root will be eliminated. So g square plus f square minus c plus r2 square is g dash square plus f dash square minus c dash plus or minus 2r1 r2. 2r1 r2 is g square plus f square minus c into g dash square plus f dash square minus c dash. This is equals to, if I expand it, a plus b, a minus b whole square, a square plus b square minus 2ab. So this is g square plus g dash square minus 2gg dash plus this is f square plus f dash square minus 2f dash is equals to, this is g square plus f square minus c plus g dash square plus f dash square minus c dash plus or minus 2 root of g square plus f square minus c into g dash square plus f dash square minus c dash. This is equals to g square g dash square, g square g dash square gets cancelled. Here f square f dash square, f square f dash square gets cancelled. So this is equals to minus c dash. We don't have c dash here because only plus c equals to, here c is missing, therefore here also c would be missing and here also c would be missing. Okay, therefore here c and c gets missed here, and so is the case here also. So students are requested to notice this change, because I wrongly have taken, because here no c's are there but c's have been taken by mistake. Okay, that c I am avoiding here from taking. So now this is okay. So what I am left with is minus of 2gg dash plus ff dash is equals to plus or minus 2 root of g square plus f square into g dash square plus f dash square. So here 2 gets cancelled, and to avoid this square root, the next step is going to be the squaring on both sides. Squaring on both sides. This is minus square would be, this is plus, this is a plus b whole square. So this is g square g dash square plus f square f dash square plus 2g g dash f dash is equals to, square and root will gets cancelled, plus or minus whole square is obviously plus. Now g square g dash square plus g square f dash square plus g dash square f square plus f square f dash square. So we can cancel g square g dash and f square f dash, g square g dash and f square f dash square. Then I will be left with g square f dash square plus g dash square f square. This 2g dash f dash, when it is transposed onto the other side, minus 2g dash f dash is equals to 0. This can be, see this, g a square plus b square minus 2ab. So this is a minus b whole square. A is g f dash, b is minus f g dash whole square. This is a square plus b square minus 2ab, because gf whole square, g f dash whole square, g dash f whole square minus 2g g dash f f dash, a square plus b square minus 2ab is equals to 0. That means this is g f dash is equals to f g dash. This is what we need to prove. Find the radical center of the following circles. 3 circles are given. The radical center is nothing but, there are 3 circles are there. There are 3 circles are there. That means one circle cuts all these 3 circles orthogonally. Orthogonal in the sense, for example, 2g g dash plus 2ff dash is equals to c plus c dash is the condition. But orthogonally, theoretically, it means the required circle cuts the 3 individual circles at right angles. So, for example, this is the circle. This circle cuts all these 3 circles orthogonally. That means the tangent drawn to these 2 circles is at 90 degrees. Likewise. So, therefore, the radical axis of these 2 circles is this. The radical axis of these 2 circles is this. And the radical axis of these 2 circles is this. So, all are intersecting at this point. So, therefore, the required circle, for the required circle, this is the center. For the required circle, which cuts all the 3 circles orthogonally, this is the center, and this center is said to be the radical center. Solution. Let us take the 3 circles be S, S dash, S double dash. So now the radical, let the radical axis of S equals to 0, comma S dash equals to 0 be L1. So that is L1 is equals to S minus S dash equals to 0. That means subtract one from the other. So x square plus y square, this minus of this. X square cancel, y square gets cancelled. Minus 4x minus of minus plus 2x. So this is minus 2x. Minus 6y plus 4y minus 2y. 5 minus of minus 5 plus 1 6 is equals to 0. If you take minus 2 as a common, then x plus y minus 3 equals to 0. Let us suppose that this is equation 1. Now, let the radical axis of, this is what? L1. Let the radical axis of f equals to 0, comma, f double dash equals to 0 be L2. Otherwise, you can take S dash and S double dash also, doesn't matter, according to your own choice. So, L2 is S minus S double dash equals to 0. So, this minus of this, x square minus x square gets cancelled, y square minus y square gets cancelled. Minus 4x minus of minus plus 6x. 6x minus 4x is 2x. Next, here minus 6y minus of minus plus minus 6y plus 2y is minus 6y plus 2y is minus 4y. Here 5, there is no constant, 5 equals to 0. Let us suppose that this is the second equation. Solving, that means actually the 3 circles given in this way, the radical axis of S equals to 0, S dash equals to 0, S double dash equals to 0. The radical axis of S equals to 0, S dash equals to 0 is this. The radical axis of these these two is, for example, this. Therefore, to obtain the point of intersection, two lines are needed. Therefore, actually, I am not taking the radical axis of these two. With the help of these two lines, if we solve, then actually the point of intersection we will be getting, and that point of intersection is said to be the radical center of the required circle, which is passing through all the three circles. Okay, so that is solving L1 comma L2 we get. Now what I am doing is I will multiply L1 with the 2 here. 2 into L1. So 2x, 2y minus 2 3s are 6 equals to 0. This is 2x minus 4y plus 5 equals to 0. This is, I am subtracting, then this is minus, this is plus, and this is minus. So 2x gets cancelled, 6y. This is minus 6 minus 5 is minus 11. If you transpose that side, is equals to 11. Therefore, y is equals to 11 by 6. Now substituting y in equation 1. That implies y is 11 by 6 minus 3 equals to 0. This is 6x plus 11 minus 6 3s are 18 equals to 0. This is 6x. 11 minus 18 is minus 7. That is equals to plus 7. Therefore, x is equals to 7 by 6. The radical center is equals to 7 by 6 comma 11 by 6. The next question, the three circles are given in this way. As usual, S dash, S double dash I have taken. So, but here, S minus S dash if I do, then x square minus 2x square. So, 1x square we will get. But the radical axis, which is the point of intersection of these two circles, is a straight line. That means a general equation of a line ax plus by plus c equals to 0 we should get. But here x square minus 2x square minus x square is what we are getting. That's why we are left with two options. Whether to divide the entire equation by 2 so that it will become the general equation. X square quotient should be 1, for which 2 if we divide, then actually 3 by 2, 5 by 2, 9 by 2, we will be getting in fractions. To avoid fraction, so we can do another process also. Instead of dividing this by 2, I can multiply this with a 2. Then 2x square gets cancelled. So in that way, let us do. Solution. Now 2s minus s dash equals to 0. L1 is, so first equation of the circle I am multiply with the 2 and subtracting from s dash. Okay, then we will do 2x square gets cancelled, 2y square gets cancelled, 2 4s are 8x. 8x minus 3x is 5x. Next, here I don't have any y, so minus 5y. Next, 2 7s are minus 14. 2 7s are, because first equation I am multiplying with the 2. 2 7s are minus 14, minus s dash, minus of minus plus 9. So minus 14 plus 9 is minus 5 equals to 0. So if I take 5 in common, x minus y minus 1 equals to 0. So let us suppose that this is first equation. And L2 is the difference of first circle and the third circle. X square cancel, y square gets cancelled. Here, this is s minus s double dash equals to 0 I'm taking. So this is 4x minus y minus 7 equals to 0. Let us take this to the second equation. So solving 1 and 2. So x minus y minus 1 equals to 0. 4x minus y minus 7 equals to 0. This is equals to, let us subtract, minus plus plus. So x minus 4x is minus 3x. These two gets cancelled. 7 minus 1 is plus 6. If you take to that side, minus 6. Therefore, x is equals to 2. Substituting x equals to 2 in any one of these equations in x equals to 0. This is 2 minus y minus 1 equals to 0. 2 minus 1 is plus 1. So therefore y equals to 1. Therefore the radical center is equals to x comma y, which is 2 comma 1. Show that the common chord of the circles, these two are given. Show that the common chord of these two circles is the diameter of the second circle and also find its length. The rough diagram for this is, these are the two circles that is given. This is the common chord. This is the common chord, and this common chord is the diameter of the second circle. So the second circle is there. This common chord is the diameter of the second circle. Let us suppose this is x equals to 0, s dash equals to 0. This is the common chord is the diameter of the second circle. So to claim it, the common chord which we are going to find. So common chord, how do we find? Simply the radical axis. Radical axis, the common chord is the radical axis for two intersecting circles. Therefore, simply s minus s dash equals to 0 I will do. Then I will be getting the radical axis. And that common chord, that is equals to radical axis which we are getting here, is the diameter of the second circle. That means this radical axis is the diameter of the second circle. That means this line must pass through the center of the second circle. That is what do we require to find, and also find its length. So the common chord's length is equals to how much? So this is, for example, this is the center and this is the perpendicular distance. This is what? This is the perpendicular distance from the center to this line. Okay, then actually this will be, the length of this is how much? 2 root of r square minus d square, which we have discussed before. The length of the chord is 2 root of r square minus d square. R is the radius of the circle and d is the perpendicular distance from the center to the line. This line is the radical axis. Okay, let us do this now. So solution, let the two circles be S and S dash. The common chord of the two circles, the radical axis, the common chord is the common chord is the radical axis for two intersecting circles. Therefore, L is S minus S dash equals to 0. Minus 6x minus of minus, so 8x minus 6x is 2x. Minus 4y plus 6y, 2y. 9 minus 23 is minus 14 equals to 0. Therefore, this is x plus y minus 7 equals to 0. So therefore, this we get. So the radical axis here, the common chord of the circles is the diameter of the second circle. The radical axis is diameter of the second circle if the center of the second circle lies on the radical axis is the diameter of the second circle if the center lies on the common chord, which is the radical axis here. Okay, so that is this common chord. So this common chord is the diameter of the second circle. That means second circle center is how much? 4, 3. This 4, 3 must lie on this radical axis, which is the common chord of the two circles. So substituting 4, 3 in x plus y minus 7 equals to 0. Therefore, 4 plus 3 minus 7 equals to 0. Therefore, this is satisfied. Therefore, 4, 3. So, 4, 3. Since 4, 3 lies implies the common chord or the radical axis is the diameter for the second circle. And so the length of the common chord, that means this is the chord and this is the center. So you may ask, sir, why can't we take the second circle into consideration? Because second circle, this chord is the diameter clearly. Therefore, I am using the first circle. So what is the center of the first circle? 3, 2. This is C. And what is this line that we got right now? X plus y minus 7 equals to 0. So this is our common chord and the line joining of the centers or perpendicular to each other. Distance, that is nothing but the perpendicular distance. So this is the length of the chord. So this length of the chord is C is the D is the perpendicular distance from the center of this circle to the line that we got earlier, x plus y minus 7 equals to 0. First, what is D? D is equal to perpendicular distance from the center of the first circle to x plus y minus 7 equals to 0. We know earlier that the perpendicular distance from px1 y1 to the line ax plus by plus c equals to 0 is modulus of ax1 plus by1 plus c by square root of a square plus b square. So in that way, d is equals to modulus in the place of x 3 plus in the place of y 2 minus 7 by square root of square of the quotient of x 1 square plus square of the quotient of y 1 square. So this is equals to 3 plus 2 5, 5 minus 7 is 2 by root 2. Since it is a modulus, minus will be taken positive. So this is equals to how much? This is root 2. And what is the radius of the first circle? Radius is, this center is equals to 3, 2. So 3 square 9, 2 square 4, minus 9. So 9 gets cancelled. Radius is equals to root 4, which is 2. So that means this is the radius. Okay. So actually the two circles are like this. Okay. Now this is R and this is D. This is square root of R square minus D square. Pythagoras theorem. So this is unknown value. So let us take A, B, C. Okay. So that is A, B, C. A, B, C is a right angle triangle. ABC is right angle triangle. Right angled at B. Now AC square is equals to AC square equals to, because this is the hypotenuse which is opposite to the 90 degrees. So AC square equals to BC square plus AB square. AC square is R square. So BC square is, this is D. D is the perpendicular distance from the center of the circle to the line. Therefore, this is D square is equals to AB square. From this, AB square equals to R square minus D square. And if you want AB, this is root of R square minus D square. And this is double. Okay. Therefore, with the 2, I just multiply. Therefore, we get a 2 root of R square minus D square. So, if you substitute in this, therefore, the length of the common chord is 2 root of R square minus D square. This is equals to 2 root of R square is 2 square, 4, minus D square is root 2 whole square is 2. So, 2 root 2. Find the equation and the length of the common chord of the following circles. 2 circles are given. Let us take S and S dash as usual. Common chord mention is there. That means we can assume, we can understand that actually the 2 circles are intersecting circles. That means the circles will be like this. So if the 2 circles are intersecting each other, then the common chord itself is nothing but the radical axis. So he is asking equation and the length of the common chord. Equation of the common chord. Common chord is nothing but it's a straight line. That's a radical axis, which is S minus S dash equals to 0. So therefore, the common chord of two intersecting circles is their radical axis and their point of intersection. So therefore, let L be the radical axis. Therefore, L is S minus S dash equals to 0. X square, y square get cancelled. 2x minus 4x is minus 2x. 2y minus 3y is minus y. 1 minus 2 is minus 1 equals to 0. If I take minus in common, 2x plus y plus 1 equals to 0. This is the radical axis. That means this is this line, L. Now, that is equation of the common chord. So, we found. Now, the length of the common chord. We have clearly discussed in the last problem, the length of the common chord. So, this is the length of the common chord. This is what is he expecting. That means this is C1 and this is C2, and so the radical axis is perpendicular to the line joining of the centers of the 2 circles. Therefore, this is perpendicular. Therefore, this is the line. We get AX plus BY plus C equals to 0, and C1, C2 we have. Therefore, to obtain D, we can take any of these circles, any of these centers of the circles, then that will be D. So this is D. What is D? D is the perpendicular distance from the center of any circles to the common chord of the radical axis. So in this way, actually D we will be getting. And so this is the radius R. Therefore, this is root of R square minus D square. And the length of the total, this is 2 times square root of R square minus D square. That's what we have discussed clearly in the last problem. Therefore, the length of the common chord is equals to 2 root of R square minus D square, where R is equals to radius of any two circles, any circle, comma, D is the perpendicular distance from the center of any circle to the line, in brackets, radical axis, that is common chord. So this is equals to, now what is the radius of the first circle? Let us take one circle. So actually if we take the radius from the for the first circle, so first circle center is to be taken into consideration, not the second. And D is the perpendicular distance from the center of the first circle to the line. Okay, so R is equals to, what is the center of this? Minus 1 minus 1. Radius is minus 1 whole square, 1 plus 1 minus 1. This is equals to 1. What is D? D is the perpendicular distance from the center. Center of the first circle is how much? Minus 1 minus 1. That means from minus 1 to minus 1. Okay, to this line. So D is equals to modulus of 2 into minus 1 minus 2 minus 1 plus 1 by square root of 2 square 4 plus 1 square 1. So minus 1 plus 1 gets cancelled. This is 2. Modulus of minus 2 is plus 2. 2 by root 5. Therefore, length is equals to 2 root of R square is 1 minus D square is 4 by 5. 2 by root 5 whole square. 2 square 4. Root 5 whole square is square root gets cancelled 5. So this is equals to 5. 1 are 5 minus 4, 1. So 2 into 1 by root 5. Therefore, this is 2 by root 5. Prove that the radical axis of the circles is the diameter of the latter circle, or the former bisects the circumference of the latter if this is the condition to be proved. That means there are two circles given. Let S dash. Former means this and latter means this. Okay. Then the radical axis of the circles is the diameter of the latter circle. First of all, radical axis we will get through subtraction of these two circles, S minus S dash. Then we will be getting one radical axis. That radical axis is the diameter of the latter circle. That means to claim that the radical axis is the diameter of the second circle, so the radical axis must pass through the center of the second circle. Then we will get this condition. Okay, so for which are given. So the radical axis of the given circles is L equals to S minus S dash equals to 0. That is equals to x square, y square get cancelled. This is 2x into g minus g dash plus 2y into f minus f dash plus c minus c dash equals to 0. So now the radical axis is the diameter of the lateral circle. So lateral circle is this. What is the center of this? Minus g dash minus f dash. Since the radical axis is the diameter of the lateral circle, that is s dash equals to 0, if the center of it must lie on the radical axis, or the radical axis is passing through the center of the second circle, whatever we can. So substituting C minus G dash minus F dash on the radical axis on the L equals to 0, that implies 2 into minus G dash into G minus G dash plus 2 y is minus f dash into f minus f dash plus c minus c dash equals to 0. This is equals to minus 2g dash into g minus g dash plus minus 2f dash into f minus f dash is equals to, this is minus of c minus c dash. If I transpose this onto another side, if I take minus in common in both of them, then this will become plus. This and this gets cancelled. Therefore, 2g dash into g minus g dash plus 2f dash into f minus f dash is equals to c minus c dash is the required condition to